Hey everyone, in the next video of our quadratic graphs, we'll be looking at the method of factorization. How we can use factorization to help us sketch the graph more effectively. Alright, so let's say we have the first example, x squared minus 3x plus 2. Alright, so there are many ways to sketch a quadratic graph. The first method you might want to think of is actually the factorization method, because you're able to catch the x-intercept if there are. Alright, so by the looks of it, well, this is factorizable because I have the factors that can subtract each other to then give me minus 3. Alright, minus 2 plus minus 1 will give me minus 3. So I then factorize to x minus 2, x minus 1. Now, why do I factorize? Whenever you sketch a graph, you need to catch the y-intercept, the x-intercept, and for the quadratic graph, the turning point as well. By factorizing, we're able to easily sieve out the x-intercepts, right? By letting y equals to 0. So we know that at y equals to 0, x minus 2, x minus 1 would equals to 0. Right? That means either x minus 2 or x minus 1 equals to 0, then we have x equals to 2 or x equals to 1. Therefore, we are able to actually catch our intercepts at 1 and 2. Alright, so the graphs will intersect here and here. Alright, so I'm just going to sketch the general shape of the graph. Try my best here. Alright, I think that's a close enough sketch. Yeah, alright. Alright, so this is not so nicely drawn one because I don't have a curved ruler, but it would make do. Alright, so let me label this graph as x squared minus 3x plus 2. Alright, now we've gotten the x-intercept, so we're left with the y-intercept, which is basically letting x equals to 0. So I know that this would be 0, 2, here would be 1, 0, here would be 2, 0. Now, the turning point of any quadratic graph that have two x roots, so two distinct x roots, would be the average of the x values at the x-intercept. So it's the average of two roots, right? So in this case, it will be 1 plus 2 over 3. So we have 3 over 2. The turning point will occur at 3 over 2. So at 3 over 2, we just need to sub that in. We get 9 over 4 minus 9 over 2 plus 2. So I'll get 2 minus 9 over 4, and I'll get minus 1 quarter. Alright, so here we'll be at 3 over 2 minus 1 quarter at the turning point. Alright, so that's the first example where you have a positive x squared, so a positive coefficient for x squared, where you have a minimum point. In the next video, we're looking at the negative coefficient of x squared using the factorization method again.